Unit 1, Topic 1.1, Operations with Numbers in Scientific Notation, or it can be called a standard form. So what is scientific notation? Scientific notation is a way to represent large and small numbers. So what is a large number? I'm going to give you some examples about large numbers. For example, 14,000. 14,000 is a large number. 158,000 is another large number. 250 is another large number. So I'm going to say that a large number is a number that is represented by some digits, I don't know, 17, followed by many zeros, so dot dot dot. Then in general, a large number is a number that is bigger than 10. Then what is a small number? Then again, I'm going to give you some examples about small numbers. Then a small number can be 14 hundredth. So 14 hundredth is 0 and 14 hundredth. Then 0 and 2000ths. So 0 and 2000ths. Or 32 millionth. So 0 and 32 millionth. They are small numbers. So if they are small numbers, I can say that a small number is going to be a number that is written after the decimal point. So I'm going to put the decimal point followed by different digits 0019. That's a small number. So I'm going to say that a small number is a number that is bigger than 0 but smaller than 1. So the question is, what is a number in scientific notation? So a number in scientific notation is going to be written as a times 10 to the power of k, where a is a number between 1 and 10, including 1 and excluding 10, and k is a positive or negative whole number, so k is an integer. So that's the form of a number in scientific notation. So you will recognize that the number is in scientific notation if and only if it is written as a times 10 to the power of k. Let's practice with some exercises here. All right, so the population of China is estimated at 1 and 412 billion. So what is a billion? A billion is 1 followed by 9 zeros. And 1 followed by 9 zeros can be written as 10 to the power of 9. So the population of China is going to be 1 and 412 times 10 to the power of 9. So we know that this is in scientific notation because the first part is between, so 1 and 412, it's between 1 and 10, right? Including 1. And then the power of 9 is an integer. So 9 is an integer, positive or negative whole numbers. Next exercise. SARS-CoV-2 is an envelovirus. Its estimated diameter is 0 and 0.00001 centimeter. The easiest way to express this number in scientific notation is going to be moving the decimal point. So move the decimal point until you have a number between 1 and 10. So I'm going to move the decimal point to the right, 1 place, 2 places, 3 places, 4, 5 places. So if I leave the decimal point there, it will be 1, then the decimal point, times 10 to the power of, I have moved the decimal point 5 places to the right, because this is a small number, the power is going to be negative. So this is 1 times 10 to the power of 9. Now this is in scientific notation because as I say, 1 is between 1 and 10, including 1, and the power of 10 is a positive or negative whole number. The last exercise is for you. How can we write 4,200 using scientific notation? So look at the decimal point. So it's at the end in this case, and move the decimal point until you have a number between 1 and 10. So moving once, 2 times, 3 times. So it will be 4 0.2 times 10 to the power of, I have moved the decimal point 3 places to the left, so to the power of 3. The power will be positive because this is a large number. Second example, this is 3 million and then 150,000. Let's repeat the same instruction. Put the decimal point at the end, move the decimal point until you have a number between 1 and 10. So by leaving the decimal point here, it will be 3.15 times 10 to the power of, I have moved the decimal point 6 places to the left. Because this is a large number, then the power is positive. The last two examples, exercise C and D. So look at the decimal point and move the decimal point until you have a number between 1 and 10. So 1, 2 times. So by leaving the decimal point, it will be 3.8 times 10 to the power of 2. But in this case, because this is a small number, the power has to be negative. So it will be 3.8 times 10 to the negative 2 power. Last example. So look at the decimal point and move the decimal point until you have a number between 1 and 10. 1 place, 2 places, 3, 4, 5, 6 places to the right. So it will be 274 times 10 to the power of negative 6. Don't forget that it's negative. The power of 10 is negative because this is a small number.